All right, so this is our, we already know that this is going to be our quadratic function, degree 2. Right, so anything that has that degree 2 will be our quadratic function. This is going to be, this is the most basic form. Think back to absolute values. You guys remember what we call the most basic form of a function? It's got a name. This is our parent function. We're going to get into more detail when we get into transforming functions later, but for now, it's our parent function. But we'll also make sure you write this part down, the general form. So our general form or general quadratic function, whatever you want to call it, looks like this: y equals ax squared plus bx plus c. So make sure you note that somewhere, because we're going to be referring to this a lot. So it needs to be written down. And hopefully these letters look familiar. We started using them in chapter 8 for a reason. The A, B, and C, right? Now, this A being out front, we've seen that letter before in terms of graphing. So there's going to be some similarities we've used that we're going to repeat back. So hopefully some of this stuff looks familiar. Okay. So for starters, let's go ahead and just get a basic graph of this parent function. So anytime you're doing something new, we just make a table of values. Patrick?
Is y equals x squared, is that the parent function?
Yes, sorry, this is the parent function. So anytime you're graphing something new, you want to create a table of values. And typically, you just want to get a good grouping of numbers, right? Negatives, positives, and 0. So let's just pick really just a couple negatives and then a few more positives. So let's start with -2, -1, 0, 1, 2. Let's go up to 3 maybe. We can even go up to 4, we don't need to though. Alright, so we're just plugging these into our parent function. So this is y equals x squared, right? That's what we're looking at right now, not the general form. So everybody, when you square -2, we get out? When you square -1, you get out? When you square 0, you get? Keep going.
4, 9.
Are you guys still sleeping? There's only like 2 people answering.
9, 16.
Thank you, Patrick. Alright, so we have a good idea of what this looks like, right? We can plot these points and we get this shape that's called a parabola. So let's plot 0, 0. We have 1, 1, and 1, -1. We have 2, 4, and then everything else, it grows pretty fast. It gets off of the graph that I have here. So let's just connect these now. Don't connect them with straight lines, we connect them with a smooth curve. So it should look like a U. So this shape is called a parabola. Okay, so one way to, well actually so far we have 2 ways to tell if you have a quadratic function. So one way to tell, identifying quadratics, you can say anything to the second power, right? That's a quadratic. This is one way to identify. The second is that you have a parabola graph, or that U-shaped graph. And then the last way that we can tell, now we did this with linear functions, we're going to do it again with quadratics. This is really kind of the most basic intro to calculus, is we're going to look at the constant change in x and how it results in y. If you guys remember that, with a linear function, a constant change in x resulted in a constant change in y. But let's look at that and see what happens. Now this works with the negatives, but you just have to think about it a little bit harder, so let's just deal with the positives here. So we're going up by 1 for all of these x values, correct? So every x value just goes up by 1. Let's see what happens with the y. So we're going to go up 1 here, so +1, +3, +5, +7. So these are clearly not constant, right? But notice what is constant. If you went one more time, this is a 2, 2, and 2. So the third way to tell that you have a parabola, or sorry, a quadratic, would be that a constant change in x, a constant change in x results in a constant second change in y. Right, so these constant 2's, and it would still work with the negatives, constant second change is what we have going on here. All right. Okay. So this is how we tell if we have quadratics. These are 3 ways to identify a quadratic. Anything to the second power, degree 2. We have a parabola, or a constant change in x results in a constant second change in y. Nelson, with this first one, I already wrote down we have a constant change in x. That's pretty clear. What's going on with the y values?
It goes down by -3, -5, and -7, and the second difference is -2.
There we go.
That means yes.
We can see pretty quickly there that these have a second change of going down by 2, so that's a yes, it's a quadratic function. This one, as the next one, as I walked around, I saw different answers. Haley, what'd you put down?
I put yes,
Why?
because I subtracted x from both sides.
Okay, it's still y. Not why do you subtract x, but why is it a quadratic function?
Because, I mean, if you look at the third function, it's y equals x squared.
There you go. That's what you're looking for right there, is that x squared. All right, next one. Eliza, yes or no?
No.
This is a no. Question to everybody, what kind of graph is this? Huh? Yeah, it's an absolute value graph, or at least as close to one that I could draw on that small graph. So this is not a quadratic. Quadratics are U-shaped. This is a definite V-shape. So that's an absolute value graph. All right. So let's move on. Let's talk about basic graphing. So I only put a couple, I think 3 graphing problems in the homework tonight, and they're going to look somewhat like this, meaning they're not a long equation. There's going to be no middle term, like there's going to be no b times x. Those are the ones we're focusing on right now. So for right now, a basic form of graphing, exactly what I wrote here. Let's just pick enough points so we can get an idea of what this graph looks like. We're going to go into a lot of detail about graphing next week and the week after, but for now, we just want to be able to do some basic graphs. So let's create a table of values. And let's go ahead and just see what this graph looks like. Maura, give us an x value.
Just any number.
Yeah, just don't pick a bad number.
3.
3 is a good one. Okay, so if we plug in 3, we get 2 times 3 squared. 3 squared is 9, so we'd get out in 18. A little large, right? So we'd have 3 here. 18 would probably be about there. Okay, Jake, give us another x value.
-1.
-1. Be careful when you're squaring negatives, right? So when you square this negative, you get a positive, so you get out at 2 here. So at -1, we go up 2. Okay, let's keep going. Bella, give us another x value.
0.
0 is almost always your best option to start with, because in this case, you just get out a 0. And normally it's really easy to plug in. Hannah, give us another x value.
2.
Let's plug in a 2. 2 squared is 4. 2 times 4 is 8. So here, we're going to be up at 8. Okay, let's get a couple more. Patrick, give us another one.
Positive 1.
Positive 1. So plug in a 1. 1 squared is 1 times 2 is 2. We have a pretty good idea now what this looks like. But just so we can see one more thing, let's plug in a -2. So we get kind of a nice amount here. If you plug in a -2, -2 squared is 4 times 2 is 8. What you're going to find, and then we'll connect them with a smooth curve, what you're going to find is that quadratics are symmetric, right? Meaning one side is the same as the other. I guess we should say that the y values are symmetric, which should make sense. So right now, the way that it is, when you plug in a -1, you get out 2. When you plug in a 1, you get out 2. So the y-axis splits this graph in half, right? So this is all for right now. This is all we're going to do for graphing. Okay, just pick a couple values. I would really stick to, most likely, these 5 are going to be your best options, and probably fairly easy to plug in. Okay. And so our vertex, all of our vertex vertices, we're going to write as an xy pair. Right? They are where our graph changes direction, the top or the bottommost point. So Ryan Hart, what is the, if you can see it, what's the xy ordered pair for this vertex for part A?
2, 4.
This is at the point 2, 4. So then, James, is that a maximum or a minimum?
It's the maximum.
It's a maximum, so that means that 4, the number 4 is your max, right? Because the graph opens down, it has a maximum, okay? volunteer to talk about both the domain and the range. Actually, let's just go one of each. So Patrick, domain.
All the numbers.
All real numbers. Every x value, it doesn't really look like it, but every x value will eventually show up on this graph. Even if you went over to positive 100, you could go down, you would eventually hit part of the graph. Now the range is a different answer. Bella?
Y is less than or equal to 4.
Y is less than or equal to 4. 4 is the maximum, right? So then all the y values have to be less than 4. Now, given what we just said, this wasn't part of the question, but someone raise your hand and tell us, what do you know about the a value? You don't know the equation, but you know something about the a value of the graph.
That's negative.
Yeah, you know that the a is negative. That's all you know. You don't. I guess you could figure out a little bit more based on the graph, but for now, all we care about is that the a is negative. Once again, we're referring to ax squared plus bx plus c. If a is negative, it opens down. All right, moving on to the next one. Will, what's our vertex?
1, -1.
1, -1. Okay, Ryan, is this a maximum or a minimum?
It is a,
This is a minimum because it's at the bottom part of the graph. Let's still take volunteers here for our domain and range. Ryan, domain.
the domain's all real numbers.
All real numbers again. Okay. Somebody else, what's our range? Yeah.
Y is greater than or equal to -1.
Okay, and then lastly, it wasn't part of the question, but let's talk about our a value. What do we know about a in this graph, Nelson?
It's positive.
A is positive because it opens up.